Okay, folks, so last video here, and just want to say thank you very much for a great class. I've really enjoyed it. In chapter 10 and 11, what we're going to do is walk through each of the different tests. So chi-square, t-test, and ANOVA, correlation and regression, what we'll be talking about in this video. And what I'll do is just walk through and say, here's what they are, and here's an example of a hypothesis that would come from this specific test. So to start with, chi-squared tests are tests of differences when both the independent variable and the dependent variable are nominal, categorical data. So we see some examples of categorical data here. We could talk about biological sex, that's either male or female. Hair color, we could go through any number of hair color. Communication strategy used, it could be aggressive, it could be assertive, it could be non-assertive. So what we would do is lump people into categories and then test the interplay there. And so here we have examples of chi-square hypotheses. A null hypothesis is what we assume, what we're trying to disprove. So what we're suggesting here is that there's no difference in individuals' preference of Coca-Cola or Pepsi. Below, we're saying individuals would prefer Pepsi over Coca-Cola. And so people are going to fill out their survey and they're going to say, I like Coke, I like Pepsi, and we're just going to kind of say which one wins, essentially. So that's a chi-square. Both the independent and the dependent variable are nominal. In a t-test, however, we have an independent variable that's nominal with two levels. So biological sex, you're either male or female. We couldn't do gender because people self-identify their gender differently. We could have male, we could have female, we could have any number of different gender examples, transgendered, androgynous, any number of things. So only two options in the independent variable, only two categories. The dependent variable is going to be an interval ratio. So think Likert or semantic differential scales here. So communication competence would be a scale that someone would fill out and then they would receive results on different questions on maybe a 7 or a 5-point scale. So our independent variable is nominal with two levels. Our dependent variable is interval or ratio. And what we're doing is comparing the different groups on the interval level variable. So we'd be comparing men and women on communication competence here. So you can see examples of t-test hypotheses here. The means of two groups are not significantly different is the general null hypothesis for any t-test you would do. In our example, there is no difference in the mean scores of men and women on the 280 exam. Now, that's the null hypothesis, suggesting no relationship. You might want to take a second to try and figure out the alternative hypothesis. So if you suggested something along the lines of men will score lower than women on the SCOM 280 exam, or when men will score higher than women on the SCOM 280 exam, you would be correct. Okay, ANOVA is exactly the same thing as a t-test, except for the independent variable has more than two levels. So here we could use gender, but the independent variable is nominal with more than two levels. So religious affiliation, you can think of any number of religious affiliations that people could put down. More than two levels. Race, more than two levels. Political affiliation, the same thing. Republican, Democrat, Independent, and so on and so forth. And we're comparing those two or more groups on, again, an interval ratio variable. So communication apprehension, relationship satisfaction, communication competence. So what we would be suggesting here is that people, if different religious affiliations, have different levels of communication apprehension. That's what we would be testing with the one-way ANOVA. And the same way with the t-test, what we're saying here, the mean of the two or more groups are not significantly different. So we're saying they have equal means. When we test differences among groups, we're testing those groups' means. So in our t-test example, we'd be talking about mean scores, not each person. The alternative here, they are significantly different. So you might want to go back to the previous slide look at those independent variables and dependent variables, and try to write a few hypotheses. Up until now, we've been talking about analyzing differences among groups or differences in categories, and now we're actually going to talk about testing relationships. The most basic test of a relationship is a correlation, and essentially in a correlation, what we're saying is, does a relationship exist between two variables? Now we can do correlations with any type of variable, but a Pearson's correlation, which is what we hear about the most, tests correlations between two interval ratio variables. The correlation coefficient is a decimal, and it indicates the type and strength of a relationship. And we'll talk about what that means in just a little bit, but are we talking about positive, negative, and how strong is the relationship? So do they move together at the same time? That's if they have a relationship or not. And then the degree of strength, which you can take a look at the chart in your book. It starts with 0.2 and goes to 0, and then all the way up to 1. Correlation coefficient can be from -1 to +1. Nothing beyond that. 0 would indicate no relationship at all. -1 would indicate the strongest possible negative correlation, meaning when one thing goes up, the other goes down. And a +1 would indicate the strongest possible positive correlation, meaning when one variable increases, the other variable increases at the same rate. So where your correlation coefficient is symbolized with an R and gives you the degree and type of relationship amongst two variables, the coefficient of determination is symbolized R squared, and it is literally just taking the correlation and squaring it. And it tells us how much variance is shared between two variables. So if we're talking about studying and grades, and we say studying time accounts for 25% of the variance in grades, that's a large chunk of variance in grades that's taken up by how much time you study. If I can explain 1/4 of your grade by how much you study, then I've actually explained a lot. And that's what the coefficient of determination does. In social science, it's all about trying to explain the variance in a variable. So what actually goes into how the grades that people get. And if I can explain 25% of those things by talking about study hours, then I've done a good job. That's what my coefficient of determination is going to explain. So here are a couple of examples of hypotheses. Studying and test scores are related. We're not saying how, positive or negative. We're not indicating that. We're just saying that these two things are related. As studying goes up, test scores is going to do something. As test scores go up or down, studying is going to do something. The interesting thing about correlation is that we don't stipulate which one's the independent and which one's the dependent variable. Though you might look at that and say, well, of course, we're saying studying is going to predict test scores. But in fact, we're not saying that because we don't actually say studying is the independent variable, test scores are the dependent variable. A correlation just says that these two things are related. All right, the second one, positive relationship. So here we're stating what type of relationship that we actually think is happening, positive as opposed to negative, exists between biological sex and communication competence. Now that's a specific type of correlation because biological sex is nominal. So that's a specific type of correlation that's not a Pearson correlation, but we can still test that. And finally, our last test is regression analysis. And regression is a very advanced and very powerful statistical technique that gets close to causality. We establish an independent variable and a dependent variable. So what we're doing is explaining the score on some outcome variable, a dependent variable, based on scores on the predictor or the independent variable. So if you study for 7 hours, you're going to get a 90%. If you study for 8 hours, you're going to get a 92%. That's what regression analysis would actually give us. Now, it does not, in any way, shape, or form, establish causality. You read earlier um, about what it takes to actually establish causality. Regression by itself does not do that. And finally, our last slide here, regression examples of hypotheses. Again, biological sex and nominal variable, we can still use that in regression, will predict communication competence. So I'm saying biological sex is the independent variable. Communication competence is the dependent variable because communication competence is dependent upon biological sex. That's what I'm saying here. Hours of study will predict test scores. Students with higher apprehension levels will report higher levels of pre-exam stress. So you might want to take some time and try and write some hypotheses and make sure that they fall with regression, they fall with correlation. They're an ANOVA, they're a t-test, they're a chi-square. Hope this helps with this. And again, thank you very much for a great summer session. You all worked hard. Really, really enjoyed those of you that participated heavily in the class.